860 tokens. That's all I got. I asked for a detailed 3,500-word explanation of quantum computing, got 3 paragraphs and a cliff edge. Bumped max tokens to 16,000. Same thing. Set num predict to -1. Unlimited. Still truncated. Every conversation with my local agent ended the same way. This is the story of how I tracked down a 2-part bug hiding in Hermes Agent's Ollama integration, and why your GGUF model might be doing the exact same thing right now. It started with a Reddit post. Someone running Hermes Agent with Ollama was getting responses chopped at around 860 tokens. Consistently. They'd set num predict to -1 in their model file. Didn't help. They'd crank max tokens in the config. Nothing. This isn't a resource problem. Ryzen 9, 4 GPUs, 128K context modeled. I was running Laguna X.2, quantized at Q4km, a model built for long-form output. And every time I'd ask it to write something substantial, it would just stop. Look at the numbers. 131,000 tokens of context available. The model used 32,000. But completions. 1,119. The finish reason was always length, not stop. Not an end-of-sequence token. The system was deliberately cutting it off. The worst part? It would then enter a truncation loop trying to continue, getting cut off again, eventually triggering context compression. It was eating my context window alive. So I started digging. The architecture is straightforward. Your prompt goes to Hermes Agent, which calls Ollama's API on port 11434, which runs inference on the GGUF model. Somewhere in that chain, a token limit was being imposed that I didn't set. First suspect, Ollama itself. But Ollama respects no predict -1 TEA. If you curl the API directly with that flag, you get unlimited output. So Ollama wasn't the problem. And here's where it gets interesting. I wasn't debugging alone. I had Hermes itself, the agent, helping investigate its own bug. And at one point, Grok jumped in too. Multiple AI agents collaborating to fix an AI agent framework. That's the world we're living in now. The agent delegated the investigation to itself. It found that Hermes max tokens was being set, but the value wasn't propagating to the Ollama API call. We were getting closer. Then I curled Abzu, my Ollama server, hit the API show endpoint to see what the model was actually reporting. And there it was. The context length, 32,000 tokens, was right there in the metadata. But it wasn't under context length. It was under Laguna.context length. Namespace by model family. Buried inside model info, not details. The parser in model metadata.py had a hard-coded list of keys to check. None of them matched. So the system fell all the way through every detection path and landed on a fallback default of 2,048 tokens. That's about 3,000 words. That's why everything was getting chopped. But that was only half the story. The primary bug was in chatcompletions.py, the file that actually constructs the API call to Ollama. When Hermes builds the request payload, it's supposed to pass through your max token setting. But for Ollama-hosted models, it wasn't applying the override. Even if you set numPredict to -1 in your config, the code wasn't propagating it to the actual API call. It was using some internal default, and that default was low. The fix was surgical. 8 lines of code. For any model endpoint on port 11434, which is Ollama's default, force numPredict equals -1 and set a max tokens floor of 16,384. But here's the thing. I applied the fix, restarted Hermes, ran the same test, and it's still truncated. That moment where you think you fixed it, and it's still broken? Yeah. That's when I found the second bug. Model metadata.py needed wildcard pattern matching. The function extract first int was doing exact key lookup. But GGUF models namespace everything. Laguna.context_length, Llama.context_length, Kin.context_length. I wrote a new function, is_GGUF family match, that checks for the family.suffix pattern across all model families. 122 tests, all passing, including new ones for GGUF family pattern matching. 2 files, 2 focused fixes. That's it. Same model, same prompt, same hardware. 21,000 context tokens. The response just kept going. Quantum computing, superposition, entanglement, real-world applications, all the way to a natural conclusion. No truncation loops, no context compression, no fighting the system. The finish reason is now stop, meaning the model decided it was done, not the infrastructure. That's how it should always work. Full QA pass. Output length regression, pass. GGUF pattern matching, pass with one minor edge case. Context detection, pass. 122 PyTest tests confirming it. And across 14 sessions after the fix, the model generated 181,000 output tokens without a single truncation. If you've been running GGUF models through Ollama with Hermes and your responses keep getting cut off, this is why. The settings you configured were never reaching the inference engine. And when the context length couldn't be read, the system was silently falling back to a 2,000 token limit. There's one edge case remaining, models that store context length under rope.scaling.original context length. Low impact, but worth noting if you're running something exotic. But the bigger lesson here is about local AI infrastructure. When you run models locally, you own the entire stack. That's powerful, but it also means bugs hide at integration boundaries. The model was fine. Ollama was fine. The agent framework had a gap in how it talked to the backend. Nobody's at fault, it's just what happens when you stack open source components. And honestly, the session crashed on me twice. The terminal got nuked. I had to restart, redelegate, re-verify. That's the real story of local AI development. It's messy. But you push through because when it works on your hardware, your terms, no API bills. This is why I document these things. Not because the fix is complicated, it's not. But because finding it requires understanding the full chain. And if you're building with local agents, you'll hit boundary bugs like this. Knowing where to look is half the battle. I push this fix upstream. Branch name, fix/llama output, limits and GGUF context. It's on GitHub right now. If this helped you, or if you've been wrestling with truncation issues in your own setup, let me know in the comments. I'll link the PR and the specific code changes below. I'm building in public with local AI agents, the wins, the crashes, and the debugging sessions where an AI agent helps fix its own framework. Subscribe if that sounds like your kind of content.